Welcome to you all, and what promises to be a very interesting webinar. We're here to examine the question, is smart technology the solution to the climate crisis? So the latest IPCC report, and IPCC, by the way, is the Intergovernmental Panel on Climate Change and is the United Nations body for assessing the science related to climate change. So the report says that having the right policies, infrastructure and technology in place to enable changes to our lifestyle and behaviour can result in 40 to 70% reduction in greenhouse gas emissions by 2050. So in other words, two of the major pillars to decarbonise the planet over the coming decades, in fact, over the coming decade, will be the appropriate use of the correct technology and human behaviour. So today we're going to talk about the appropriate technologies, more commonly known as smart devices, smart cities, smart cars, and that smartness, the smart piece of it is created and provided by data. And that's what, it's what gives the hardware the intelligence and insights needed to be smart. So today, we will be joined by people who are using that data in their own fields to reduce the inherent carbon in their own industries. We have Amy Marks, VP of Industrialized Construction, better known as, and much easier to get your tongue around, the Queen of Prefab. Also joining us is Alan Keogh, CEO of Coolplanet, and our very own founder of Host in Ireland, Garry Connolly. So, Garry, I'm going to start with you, and let's start with smart technology. The title of this is smart technology. So, I would love to know from you, a topic close to your heart, as our resident smart aleck. You can tell me a little bit about smart technology.
Thank you so much, Michelle, and thank you everybody for joining us this morning. I must remind Amy that when you say prefabrication to people, or fabrication to most people in Ireland, they shiver, because that's where we spent our junior infants in school before they built the school. So be aware of that. But what I tried to do, Michelle, actually was just before we get into a load of wordage, I looked up and I actually Googled, what is the definition of a smart device, right? So I have to put on my Harry Potter glasses to read this, but it's a wired or wireless, context-aware, electronic device capable of performing autonomous computing and connecting to other devices for data exchange, storage, compute. So the usual old nonsense from technological people and giving it to marketing people gone nuts, right? In real terms, what is a smart device? Well, I thought about this. If my hand is a smart device, my brain is actually giving it the smarts. The hand itself, like a lot of the devices we have, is just metal, plastic, silicone. It doesn't do very much. The brain behind it, and what actually gives it the smarts, is data. And why does that matter to people? Well, we're now recognized, you mentioned the United Nations and the IPCC, we're recognized now, and a lot of people on this call and will recognize Industry 4.0, Agriculture 4.0, Manufacturing 4.0, 4.0, and very few people actually know what the 4.0 stands for. It's actually, we are currently in the fourth phase of industrialization of the globe, the Industrial Revolution 4.0. And if anybody remembers, which I didn't until I learned it again, that the first industrial revolution around the 1700s was actually created by steam. But steam wasn't invented then. It was the application of the steam onto a piston. So it was the actual insights and directiveness of steam onto a piston created an engine. The engine then was able to go into the mines. The mines were able to take out the water. And then we got coal and all these other things that we now realize have got us into where we are today. But that effectively, the steam of the 2022 or the fourth industrial revolution is data. So it's the data that gives the smarts to the equipment. So I'll finish off by saying, when people talk to me about decarbonization of society, cities, transport, agriculture, and probably any other sector of the planet's challenges around carbon, they always talk about smart technologies, smart devices. So what I would like people to remember is it's hardware and it's data. The data is what gives the smarts to whatever you're trying to do. And here's the thing that we would love everybody to realize: that data needs to be kept out of the rain in a center. So that's why we have centers. It's not all Facebook. It's certainly not all Snapchat. And actually, it's not all Netflix. That's only 8% of the world's data today is associated with social media. All of the rest of it is actually your data, corporations' data, and most importantly, as we move forward, making tools to decarbonizing so many parts of our global society.
Super. Thanks, Garry. And I love that analogy of the hand and the brain, actually. That's a nice way of thinking about it. Nice way of putting it. Thank you.
Is this being recorded? Because you rarely say nice things.
No, we do. We turned off the recording just for that moment.
I thought so. Thank you.
It's grand. Yeah. And Amy, I'd love to come to you now, because actually Garry's set it up nicely. We're talking about the centres and the building part of it. So can you tell me about your involvement in the smart technology? What's the smart piece of your puzzle?
I think first of all, I've never been called queen of the portables before, or of the trailers before. So this week I was called queen of platform instead of prefab. But I think, look, at the end of the day, we're a highly instrumented society. And what do you do with that data? And how are you using that for data-driven decisions so we have a better planet? And I think, it's good timing. Autodesk just put out our impact report, I think this last week. And if you're, we hear about smart cities and but if you're going to construct them in the dumbest possible way, how smart are they? So, 40% of what's in our landfills is construction waste. 1/6 of that is drywall. And I think if you're not thinking about things to make, the data centers smarter when you're constructing them, or semiconductor plants or schools or hospitals or any type of building, if you're cutting and welding unproductively on site because someone designed something without the smarts, without the intelligence in their building information model, we have to start designing things how things could be actually manufactured. So many data centers have already productized their kits of parts so that you can inform the design with manufacturing instead of, creating waste. I always say digital waste exponentially leads to physical waste. And so we have to recognize that people want to make data-driven decisions, but it's difficult because even though you can keep the data out of the rain in a data center, we've got to actually get clean data from our operational, carbon, what's going on when we operate these buildings, so that when we actually want to choose and select things for embodied carbon upfront in our designs, we want to pick the right combination of parts, the right materials to make sure, using things like EC3 and getting the proper documentation and understanding that you can use technology to make some of those decisions right now. But I think we're a little bit far away from where we want to be for circularity, because you have to really enable that through connected data. That's been the difficulty. We have lots of data, some of which is still disconnected, but I do believe that, connecting that, I know platform in Europe is a dirty, dirty word, but we need open platforms that enable lots of digital glue to connect the data to make the right decisions.
Brilliant. Thanks, Amy. And actually, Alan, that kind of brings you in here really, because you're, while Amy is looking at the build and that initial stage, and you almost have a blank canvas to start with, Amy, you've got the complete opposite. Alan, you're coming in legacy buildings, in kind of, once the buildings are up and running, they're operating, they've, however they were built, whether it was smart or not, and you're then coming in. Tell us a little bit about that and about your role in that.
Yeah, sure. Yeah, no problem. So yeah, we come across all kinds of buildings and factories in different kinds of states. Some buildings and factories are relatively new, and they've been designed using all the great tools and solutions that Amy provides to be smart, theoretically. And we had come across other buildings of factories that, are a long time around, and, maybe something was added on 10 years ago and something that was added on 5 years ago, and so on and so on. And they've just been kind of added to in an unstrategic fashion, if you want to call it that. On the first example, we have lots of examples where we've gone into, very complex factories that have all the smart devices and all the really cool kit, whether it's variable speed drives on refrigeration plants and meters and sensors and data potentially up the wazoo, data everywhere. But really the smart bit is actually gaining access to that data, sucking it out of the factory, putting it in a central place so you can do analysis with it. And we've had results where we've got, brand new factories or factories that are a year or two old, where we've still taken 20 or 30% off the energy consumption of that factory and the carbon emissions associated with it, just by actually being the conductor, as it were. So we kind of think about it as the factory is, all the bits and pieces are different instruments, and the tubo and cello and all the rest, and we try and bring all the data together in a smart fashion and be the conductor, so that they all play together in a kind of coherent manner and deliver energy savings ultimately. And then we also have the other example where we're going into factories and buildings that are very old and been added onto, as I say, in a kind of haphazard fashion. And really the challenge there is trying to suck data out of dark corners, where there's an air compressor in a plant room that nobody ever goes into because it's in the basement and it's full of water. Being able to suck data out of that air compressor, bring it to a central point, see the opportunity to make it more efficient or coordinate it with the rest of the air compressors and save 20, 30% as an example.
Brilliant. So you're building on what Amy was saying about having those kind of, you're creating those connections between the different pieces of hardware, different platforms, to actually get that data, connect them together in a smart way, and to make the savings that way. Is that right?
Exactly. And then be able to bring to bear. So we have a team of world experts located in various locations around the world. So instead of being able to, or having to fly them to the factory to maybe look at some piece of data that isn't available when they arrive, which used to happen all the time, can we suck that data out, maybe add some new sensors, connect to different various pieces of equipment in the factory, suck it up into the cloud, and not just in one factory, but we have customers where we're doing that across 50 or 60 factories. And being able to benchmark one factory to another is very powerful. But then to be able to apply world expertise to the data, and this is even before any kind of potentially smart stuff like AI or ML, park all that stuff. The basics of being able to just see data and see opportunities is very powerful, and get the right eyes on the data at the right time.
Wow, that's incredible. So, when we talk about, we talked about the IPCC report at the start, and that 40 to 70% reduction in carbon, you can achieve 30% almost right now without, kind of additional AI and technologies added on top of that, which could
absolutely, yeah. Just doing the basics, the basics are, it's like that part, to paraphrase that phrase, common sense is surprisingly uncommon sometimes, so just being able to see the data and get the right eyes and the right data at the right time, it's very powerful.
That's it. And what Amy said, there's all this data everywhere, but we have to be able to make sense of it. And so look, we've looked at smart technology briefly, right? And now I want to get a little bit deeper into the climate crisis part, right? Is smart technology the solution to the climate crisis? And when we talk about climate crisis, obviously we've touched on a little bit, we're talking about carbon a lot of the time. Can you give me, Alan, a very high level overview of carbon, where it comes from? Everything we do basically in one form or another generates carbon, right? And it's measured, we're starting to hear more about scope 1, scope 2, scope 3. People will have heard of it, some people won't. Can you give me a really kind of high level overview of what that is and how it's measured?
Yeah, sure. Yeah. And just to say, carbon isn't the only problem. So carbon is a global warming gas, obviously, but there are others, and a lot of others are much more potent than carbon. So methane, for example, is a lot more potent than carbon in terms of global warming potential. So our carbon dioxide, to be specific. So there are a number of different what are called scopes, and what they're trying to describe is how the carbon is emitted. So everybody hopefully has heard of scope 1, 2, and 3. So scope 1 is hopefully the easiest to understand. It's if you have a factory you combust natural gas or oil or some kind of fuel to generate heat to, you know, cook whatever it is, foods you're cooking in your factory. You got to fire natural gas in your boiler. That natural gas, when you fire, generates CO2, and that becomes a global warming gas. So that's scope 1 emissions. So combustion of gases on a site, but also other gases like leaks of refrigerants. So refrigerants, different types of refrigerant can have a global warming potential. So if you've got a chiller on your site that's leaking refrigerant, that's scope 1 emissions as well. Scope 2 is a little bit removed. So it's due to the electricity that you buy to power your factory. So that electricity comes from generally a fossil fuel powered power plant down the road, whether it's coal, gas, or oil, and that power plant has to combust those fuels to generate electricity, and the CO2 emissions associated with that power generation is scope 2. And then scope 3 is really the thorniest or the trickiest one, both to measure and to abate. And scope 3 emissions are related to your supply chain. So everything into your factory and everything out of your factory downstream. So for example, if you take the beef industry, probably 98% of their overall carbon emissions come from scope 3 emissions, because there's millions of cows in fields belching away methane, which is a very powerful greenhouse gas. But then if you're trying to track their scope 3 emissions in the beef industry, you know, how far do you go downstream in the downstream chain? You know, do you include the gas that's required to cook your steak ultimately in your kitchen or not, and who's going to account for that, and who's going to take control of that and try and reduce that gas in the kitchen. So that's the kind of thorniest one, I suppose. So scope 1 being the easiest, scope 2 a little bit more removed from the factory, and scope 3 being quite difficult and complex.
Gotcha. So we need to just start thinking outside our own kind of, you know, immediate view and start looking far longer down the chain. And I think that's really interesting when we're looking at businesses and organizations and how we can influence the supply chain as well, because when we're ensuring that part of the procurement process is including, you know, high standards around, you know, carbon and emissions and you know, and measuring that, then I think like we can start to at least make an immediate difference. And certainly start to change some longer term behaviours and expectations around it. So thank you for that, Alan, and I think hopefully that's clear things up for people. Amy, I'd love to get back to you now. You talked a little bit about your role in construction, and you talked a little bit about manufacturing buildings. So can you give me a little bit of a picture of kind of what's happened in the last few years? Like how have we moved, and what does the traditional kind of build look like versus this kind of new way of building? And I love, you know, you said there 40% of landfill is construction waste. Like what? Can you give us a little bit more kind of color around that, and how things have changed and what the future looks like?
Sure. I mean, and by the way, with all of these regulations and all these incentives, we have very little, if any, incentive for waste avoidance. So people don't actually give you credits for waste avoidance. They give you credits for when you sort the waste correctly, or when you're in construction, at least. So we have to really start pushing for waste avoidance. And one of the ways that what I call serial owners that own 30 data centers or 20 hospitals or 100 schools are looking to actually avoid waste is by creating a playbook where they enable kits of parts and where people are productizing what used to be process on site. So they're looking at things like electrical, instead of, you know, doing it piece by piece, they're making electrical skids, or they're doing, you know, HVAC racks and risers that are built in factories and then brought out to site. So if you can identify kits of parts that can be made efficiently and actually understand the embodied carbon of those and operational carbon later, that is a better world than if you're just designing something and hoping it can be made in sustainable practices. So Autodesk has actually invested in something called manufacturing informed design, where we are actually taking our manufacturing tools to identify how to make things with the makers of the world, the manufacturers, and the people that are fabricating very complex types of equipment, not the school building that you used to work in, but things for semiconductor plants and data centers and even schools, big permanent schools. But what is that piece part, and what are the characteristics? What's the data associated with it? How it's made? what sustainability practices are used, what materials, so that we can avoid waste, right? So they call me the queen of prefab. When I redid my house, I had a dumpster outside in my driveway, a bin, because I have 100% of my old bathroom is going into that bin, and 50% of probably the new bathroom went in that bin if you don't buy a manufactured part. Now, I can't buy a manufactured bathroom right now as a consumer, but many of our serial owners that are working on the commercial sector have the opportunity to inform their designs for operational consistency, really, so that they can identify which manufactured pieces and parts can inform the designers to consume that data in order to make sure that their building operationally later doesn't have the types of losses that Alan's talking about. And that data exists today. So at Autodesk, we look at a little bit differently on our impact, not only for ourselves and what we utilize, but how can we enable digitization of every customer designing a building, of every customer engineering a building that wants to utilize sustainable practices. Our multiplier effect, when people are using AutoCAD or Revit or even Inventor or Fusion or our Autodesk Construction Cloud, they have the ability to impact so many buildings. And that's why it's a little bit different than just what's one group's behavior. How do we impact many groups' behavior by understanding the true nature of what can be manufactured most efficiently so that we don't have millions of dumpsters out in job sites filled with waste for no reason, that we just didn't design it the way it was most efficiently made.
I love that. And to think, back to that kind of 40% piece, and that's not encouraged or measured or so we need scope 4 basically. So Amy, your homework today is to go off and design scope 4 for waste avoidance.
I have a lot of homework right now, but yes, I'll try.
Can you, I know you've kind of touched on a little bit, I'd like to just kind of talk a little bit about a quick definition, just for clarity, on carbon emissions versus embedded carbon. What's the difference? Why does it matter? And what are we trying to impact?
So embodied carbon are, for at least when you're designing a building, they're looking at the carbon that's produced, as Alan was talking about, from each piece part. What's the environmental data that you know about that particular piece of equipment that you're thinking about incorporating into the building, or that material that you want to put into the building? So we have to look at sort of carbon in its first phase when we select materials that we're going to, transport to the job site, utilize in the building. But then we also want to look at operational carbon. So that's embodied carbon. We think of it in that way, that first phase. And then we want to think operationally, like, even though I selected something that had potentially low embodied carbon, operationally is where much of the sustainability can happen. So we have to look at both when you're looking at a building. One of the cool things about what's happening now in the space of data with these buildings and with new tech that's happening is that, I'm not sure if you've heard of, this is my Apple phone. I like to use this as the example. When I bought my phone, it didn't have many apps in the beginning, right? So it had sort of, there were some apps in the App Store. We have the same thing at Autodesk. We have an open platform that has sort of preloaded apps in the cloud, whether that's the Construction Cloud products or Fusion or any of our other products like SpaceMaker, where we're looking at understanding the combination early days. But now it's a really great time for data, for a lot of the homework that you probably should give to other people, in that our operating system at Autodesk in the cloud runs on something called Forge. And it enables these interfaces with other products around the world, our products, competitive products. But those apps, there's about 4,000 apps that have been built so far, and about 100 apps a month. So I am looking for, and we actually have a foundation that looks at targeting and helping companies actually build the next apps that are coming out to, think of things like sustainability and the digital glue that has to connect that data. So I say to Garry, I wouldn't be here if I made money on the internet early days. I made some, but not enough. Right now, look, I always say Waze lives on my Apple phone, and so does Google Maps. So does WhatsApp. I used to live Tinder on my phone. Who makes the new WhatsApp? Who makes the new carbon, the next thing that affects sustainability in the cloud that people can use to change this behavior, to create more data rivers instead of data lakes out there for this? This is a really brand new world where you can take the data and actually do something with it for the betterment of business as well as the climate and what we're doing on this planet. It's a really exciting time for data, how it can affect the way we live.
The Tinder on your phone is for the later after hours show.
I don't have that on my phone anymore.
This is a daytime show.
I don't have that anymore. Lots of different kinds of apps.
All right.
Thanks for that, Amy. And thanks, Garry. So you've covered kind of a couple of things there, from the construction side to the forge, like this platform with all of these apps that help create this digital glue. And if we're talking about this 40 to 70% reduction in carbon that we need to do, like, what's the impact, do you think, of this new way of manufacturing buildings? What's the kind of carbon reduction we can take from that? Or I know it's because it's open source, it's so unknown, but potentially this digital glue that's formed with these apps joining things together to be more sustainable. What do you think is the potential impact from some of that?
Well, I mean, it's tremendous. Just first of all, productization and using manufacturing informed design, I believe, and I've heard our CEO say this, might be the single most important thing you can do for waste avoidance on this planet. But you truly have to look across at Autodesk. We're looking at, energy and materials, health and resilience, but also work and prosperity. How are we looking at the people in this data conversation? So we're creating better places for them to work and live, and make sure that we're creating the skills and the learning that's needed for this future state. So I think there's a lot of impact on the energy and materials related to the waste and the supply chain we've talked about. I think there's a lot in the that you'll see in places and products that create a safer, sort of healthier, more resilient planet. So it's multifaceted. So it really depends on how you're defining impact. But I think, look, almost like Alan said, you can do almost this much today that has tremendous impact. Just again, avoiding the waste in our landfills, or designing with the most, carbon, responsible materials and assemblies that you can think about. That's really where we're going to make the most gains today. And I think all those fine details of some of the cool technology that's out there that's yet to be created and incorporated, that's going to get us even further. But I think we have yet to, first we have to really get digitized and start connecting this data so that we can actually understand the most efficient workflows that reduce these things. Right now, we're sort of cash for chaos in some places still, right? It's like people are making money off the inefficiencies of the silos and the lack of data. People make money off of that these days. I mean, they make money off of the inefficiencies that are created from that. I'm not going to point any fingers on the panel, but I feel that and that's okay. Like, we should be making money on those things at the moment if you're making the world a better place. But a lot of that money that's being made is on waste. We have to stop paying on waste and recognize that that's probably creating the most inefficient. If you're paying for drawings that are never going to be built, or you're going out for multiple, RFPs for stuff that's never going to be purchased and it's never going to be built in that way, or if we're just doing, again, digital waste that's exponentially leading to physical waste, that's where we can really make the biggest impact, I think. And I don't even know if we can measure that at this point. Yeah. But I think we can do a little bit today to make a huge impact.
Thanks, Amy. And that's a nice little segue into you, Alan. Then you're dealing with a legacy.
I'm glad it's this segue and not the Tinder segue. So
yeah. No, we've left that behind. But you're dealing with this kind of legacy systems, equipment, buildings, processes. Like you're dealing with a lot of older stuff. Is it not just better to chuck it all out and kind of start from scratch with something that's has super efficiencies built in?
Well, no, I would say is the answer. I mean, it's a very valid point and question. I mean, I think 90% of the factories that are exist currently are going to be around in 20 or 30 years time. These are, especially if you get into something like semiconductors or biopharma, these are $1 billion, $2 billion assets that they're not just gonna throw out. I'm just getting some feedback there. I'm not sure if it's from me or.
No,
hear me okay?
It was me looking at you on LinkedIn. You look well.
Okay, thanks. Back to the Tinder segue, yeah.
Oh,
we're just going to put Garry on mute now. Alan, go on, Garry.
So I mean, 90% of those facilities, buildings, factories are going to be around in 20 or 30 years time. You know, they're big investments. You know, people, you know, like houses, for example. You know, like I generally live like where I live. I'm probably not going to knock it down and build a new house, and that's not the most efficient thing to do. If you are doing that and someone's building a new house, obviously it should be done in the manner that Amy's talking about, as efficiently as possible and minimize waste. But you know, like there's a massive opportunity in the existing housing stock, building stock, and factory stock to make them much more efficient. I mean, the 20-30% I talked about at the start of the discussion, you know, that's just the energy efficiency slice, you know, of decarbonization, 20-30%. But I've just come from a meeting where we're looking at integrating a heat pump into an existing brewery, and data is really making that job much more easier, because it's not just take it out of the box and plug it in. This all the heat has to be integrated into the various heat loads around the factory. Having the data, which we do because we're already connected to the factory, makes that job a lot easier. But we're looking at an 80% or 90% decarbonization results. So I mean, those technologies are there to make the existing stock of buildings and factories much more efficient. That's where we spend a lot of our time.
Yeah, but Alan, let me jump in for a minute. The reason you can't do what you just asked, Michelle, is that many of these buildings were designed to be sort of, all the systems are sort of intertwined. They weren't decoupled to be swapped out when technology changed, right? And so if you think of biopharma or semiconductor or even data centers, now it's a little bit different. We're looking at understanding decoupling of these systems so they can be upgraded, or we can scale capacity, or we can change the technology. And that truly is productization of those systems to be swapped, and hopefully for circular economy to be reused, right? So it's very hard when you design something when you weren't thinking about reuse or upscaling or capacity. That's almost impossible. So now with digital twins, like when we're thinking about things like Tandem at Autodesk, what's the data on these current systems we can collect? When we decouple them and understand IoT sensors on these kits of parts, and then we can see them operationally, what different choices can we make based on the current operational outputs of these buildings? What do we learn from that? How do we understand them later? We don't have a lot of understanding when things were just woven together without much instrumentation. So it's a different world.
For sure. And, you know, the reason I asked that question is because what I want to get into now is a little bit about human behavior. Because when we think about, oh, what can we do individually? What can we do as companies? Sometimes we jump to the new thing, right? Rather than thinking, what can we do with our existing thing? And so I want to, and going back to the IPCC report, part of that is about human behavior, and it's us. We're the people. It's not the technology itself that has the finger on the on or off button, right? We're the ones who are setting it off. And so I'm not sure I can actually think of one example of any business that's operating that doesn't depend on data in one form or another. Like if it accepts money, it's going to use data in some form. So Garry, I'd like to bring you in on this, and I'd like you to talk about human behavior. And Alan, I think then I'd love to bring you in a little bit on kind of building on that in institutional behavior and these kind of drivers for change. So
there's so many old sayings that we should be reminded of, like there's nothing as queer as folk. Alan came out with a great one earlier, and it's probably more relevant now than ever. It's, common sense is not as common as you'd like to believe. But the one that I like to bring up right now is that the one thing that we've learned from history is that we've learned nothing from history. Okay? What do we mean by that? We're talking about an asset class here. Amy's heavily involved in the data centers. They're going through an evolutionary ego, get over your ego phase that the retail, the hospitality, the hotel industry went 30 years ago. Now they plug it all together. 5-star, 3-star, 2-star, doesn't matter the flag. They have a set format for how to deliver a Radisson 6-star or a Radisson 2-star, and they have it worked out. So what's different? Well, the bricks and the mortar and the engineers is the same. It's the industry's ego. It's human behavior. Oh, and what do we then talk about? We then talk about every industry and every generation thinks it's invented music when there's only 12 notes. And that's what we need to continuously go back to. It's probably been done before. have I got the confidence in myself to look back, to learn, to bring it forward, right? The next part of human behavior is all around sort of what I like to call the 4 Bs for how we're going to get ourselves on the right track and out of the deep, deep hole that we find ourselves in. Well, what are the 5 Bs? Well, we got to look at what we buy, everything of what we buy, where it comes from, what it's made from. That'll affect your personal consumption, which will affect the market capitalization of the companies that you're buying from and the geography of where you're buying from. The second one is what we bite. I loved so much, Alan, thank you so much for bringing in the fact that greenhouse gases are not just carbon, because they're not. And everybody, it's a bit like GDPR when it came on the scene a couple of years ago. Somebody went on an overnight course and they were a GDPR expert. You know, they're not. And all these ESG new consultants that come out, they would make the rookie mistake of thinking that carbon is all our challenge, when in actual fact, as Alan said there, what we bite, i.e. what we eat, has such an effect on the planet. What we burn, the 3rd B, we're always going to burn something. We now need to change from burning fossil-based stuff to stuff that's made from green, hydrogen, for instance. And then finally, and bringing it back to this particular session, what we binge on. You want to stop the internet growth? Stop binging on Netflix then. Stop binging on Revolut. Stop binging on social media. Stop going to the hospital when you feel bad. Stop all digital services. That's fine. But we need to look at what we binge on. So ultimately, human behavior is probably the greatest asset we have to reverse and the greatest hindrance that we have to actually get ourselves out of the hole. Alan, you asked Alan and you asked Amy about retrofitting. Now, I'm going to get this wrong, and I'm sure people will get it right, but there was always 3 things, wasn't there? Reuse, refurb, before you replace, something like that. Yeah, that's just normal house usage, right? The embedded carbon in a building, if we're talking about buildings, my understanding is that cement, steel, and glass globally are responsible for over 8% of all emissions. 8%. And yet we tear down buildings and we dig up all this concrete for new, more concrete. So do we have to go and engineer something? No, that's just common sense. Look back at what we've done before. And the final thing about, I'd like to say about human behavior is Alan, Amy, all the people that I meet that have different platforms in it, the tools are there. The tools are there. Go find them. My woodwork teacher, I was the worst woodwork kid in school, right? The worst. The only thing I remember was measure twice, cut once. That was all. Measure twice, cut once. Whereas everybody dives into your point, Michelle, to the new technology. Oh, I want the new shiniest thing. And I want to get rid of the legacy because that guy before me was useless. Let's just stop. Let's reuse. Let's look at digital twins. Imagine we can actually recreate a multi-billion city, multi-hundred billion city we can digital twin before we even dig one hole.
So I'm going to ask, because we've said digital twin a couple of times, what's a digital twin?
It's just a recreation of whatever you're doing using data.
It's Garry's Tinder profile.
Listen, you're the one that keeps bringing that back up. So if you can imagine, Michelle, that particularly as Amy will highlight, you go on site and a particular pipe is in the wrong place, and that means the whole thing has to be taken out, and that goes on the landfill. You recreate a digital version of that you can touch, feel, and go on site with.
Yeah, we want to take it a little further than just like what you said, where the pipe is digitally represented. You know, that's building information modeling, right? So we have models of these buildings that are digitally represented. The true nature of digital twins at the end is you don't just want a digital representation of the building at the end and how it's operating so that you can understand, you know, hopefully we move to autonomous buildings that we get data on all the time. So we understand both its efficiency and the end user experience in it. But true digital twin, and by the way, there are experts. We sit on the digital twin consortium actually at Autodesk, and I participate in some of those meetings sometimes. But at the end of the day, there are lots of definitions of it at the moment. But I truly believe it starts with the data early enough, with the piece parts that are informing that digital representation, and what the data backbone that we know about those pieces will tell us later on down the road. Are there IoT sensors informing how it was made, how it was transported? When we made the decision to incorporate into the design, how did we use the data? By the way, Garry, I think it's interesting you said behavior. You know why we keep learning the same things over and over again? It's because we have short memories. And lots of these things, I'm 50 years old, we're all older. We have a lot of anecdotes, but we have very little sticky tech that gives us the actual data to change our behavior with data-driven decisions. That's why we keep making these same mistakes. We forget the stories, the person that lived it goes away, but this data that you can get from this digital twin understanding in its future state will make that tech sticky for the right kinds of data-driven decisions that humans can change their behavior based on.
Should they desire to go and use it?
Yeah, right. By the way, I got to tell you a funny story, Garry. My friend said before COVID, they couldn't go paperless. They couldn't go e-signatures on anything in construction. He said 3 days after COVID, all of a sudden they're paperless and he can do e-signature. And I said, look, technology didn't change in 3 days. Your interaction of your behavior and your technology choices changed in 3 days.
Everything is impossible. Everything is impossible until it's not. Yeah.
Just Michelle, I'll give you our tech twist on the digital twin story from the kind of retrofit business or the downstream businesses. I suppose we build digital twins of factories, very complex factories all the time, and that digital twin is a representation of that factory living its best life, if you want to talk about it in that way. So it's what the factory can do and how it can perform, and weaving in the human behavior thing. It doesn't perform that way a lot of the time because, one operator on one shift likes to run the plant this way at this temperature set point because he feels more comfortable. And then the next operator comes in the next shift and he runs it at 78 versus 82 and, reduces energy consumption by 5 or 10%. So if you can have a smart digital twin populated by live data coming in from the plant, sitting in the cloud, saying, look, this is what you could be running at, and there's no good reason why you're running it this way. And then to work with the factory plant manager and operators to say, look, there's no good reason for you to run the factory this way or the refrigeration plant or whatever it is. So that's the power of digital twin is for us. It's getting into, what I started at the start saying, look, it's the basics sometimes that can deliver big results. But, the next level is having that digital twin saying, you kind of operate this way at this performance. Why don't we look at doing that?
Yeah, super.
But you've brought up a great thing, Michelle, because what you've highlighted is, again, and you asked Alan to qualify it on the scopes. We use words that we think people understand, and yet they don't. Really, for most people, if you were to say a model, a digital model, that's the same as a twin. Okay, it's all more sophisticated and it takes other feeds, but it's really just a digital model, all grown up.
Yeah,
it could be a spreadsheet,
to the exact point. It doesn't actually matter what the platform is. Once it's giving you timely, accurate, and actionable information, it doesn't matter. You can call it whatever you want. But it's sexier to call it a digital twin because that's what everybody else is calling it today, right?
Now, I'm just, because we're about 13 minutes off the end of the webinar, I just want to remind the audience, if they do want to ask some questions at this point, pop them in the Q&A at the bottom. We've got some questions coming in there, so we will get to those in just a minute. I'm going to give you an opportunity, Alan, just to talk a little bit about that kind of the institutional behaviors, right? So, you go in, you implement changes, you've got all the, and this kind of comes to one of the questions in a way, you've got ESG guidelines, all the rest, and nothing changes.
Yeah, I could talk about that. We spend a lot of our time kind of dealing with that, I suppose. And I suppose an analogy could be, 20 years ago, 30 years ago, health and safety was nowhere near where it is today. Now, obviously, some businesses are better than others, but compared to where we were 30, 40 years ago in the construction industry and industry generally, it's night and day. And, you know, that light bulb went on, you know, 20, 30 years ago to say, well, it's not really acceptable for people to be killed at work or to go home seriously injured. Like, they're avoidable. Every accident is avoidable ultimately through better design or better operation or whatever it is. And the decarbonization challenge is similar, but maybe bigger as well, because, you know, it includes the whole organization. So to your point earlier about, you know, procurement and finance, you know, now procurement and finance people are sitting there going, well, that's just someone else's problem. But actually it's not. You know, you got to account for carbon like you do. You got to account for money on your P&L and your balance sheet. You got to buy the right equipment. You got to pay a little bit more for the right equipment because it decarbonizes your plant and operation further. So weaving that throughout the organization is going to be a major challenge. And, you know, our kind of analogy is, you know, if you want to lose weight, maybe politically incorrectly, you know, you don't drink a kind of Diet Coke. You know, you got to do the Ironman or triathlon. Unfortunately, you know, you got to put the effort in to decarbonize and lose weight. You know, putting solar on the roof is a good first step, but it's probably only 6% of your electricity supply. And it's easy, you know, buying green power and going to the press and saying, we've done this, you know, okay, it's a good first step, but generally it was very easy to do. You might have paid 2% more for your power, which isn't very much. Maybe at the moment it is, but generally it hasn't been that, you know, that expensive to do that. And like anything that's difficult, you know, if you think it's an easy solution for it, you know, you're kind of drilling yourself ultimately.
Yeah, thanks.
But Alan, you're saying we have to start measuring our behavior. Truly, it's not enough just to say you're doing things. I mean, again, I really encourage people to go out and read companies' impact reports. Our impact report just came out. We've reduced our scope 1 and 2 by 37% compared to a couple of years ago. We doubled our internal price on carbon from $10 to $20 per metric ton. I mean, you're talking about things like $1 billion sustainability bonds and almost, you know, $18.5 million, I think, in philanthropic funding by our foundation for new solutions. But we're measuring that and we're putting it out there every year. And you can read all about these things. You need to start, look, you have to start understanding the companies you're doing business with and making choices if those are the behaviors you want to support.
Yeah,
right?
For sure. And actually a great point. We've got a question in here, you know, saying a lot of companies are fudging their ESG policies by simply buying carbon credits, then claiming being carbon neutral, when in reality, they're just making it somebody else's problem. How do we stop this and really use actual technology to call this type of messing out? So I think that's, so Amy, are you saying it's transparency all the way?
I think it's transparency. I mean, look, you can go and read our impact report. I think, look, you're asking for the laws to be changed on how people can count their, you know, carbon neutrality at this point. That's sort of out of my pay scale, as I say. But I do think transparency and reading about what's actually going on and not anecdotally what we think is going on with companies, really just learn about the companies you do business with. And that's why supply chain diversity, you know, programs have popped up and sustainable practices within you know, supply chain selection has happened. I think it's really important. And also, look, every company can't do the same thing, right? So I believe at Autodesk, we have such an ability to impact other people's sustainability stories that when I sat on the steering committee for that, that was a big conversation, not just our own sustainability. How do we impact companies around us to be more sustainable? Now, some companies don't have that ability. So I think transparency and understanding where we're best suited to make the biggest change is important.
Yeah. But what we find ourselves is in a world now that people actually don't make enough informed decisions.
Right.
Personally, sectorially, policy-wise, they make often what's the popular or the populist decision.
Right.
And that's driving us into a hole. That's driving us into a hole. So now what we would like people to start to do is read further than the 140 characters on the Twitter.
Right.
Get behind the if it bleeds, it leads headline. Put like good qualification, like what Alan did when we talked about, you know, greenhouse gases. Understand that there's more than just one. Understand that if you don't eat that burger tomorrow, you possibly have had a better positive effect on your carbon footprint than your whole year's length of electricity.
Right.
You know, because what comes popular, it becomes populist. And then it's, you know, in the reverse of it, and I'm sure Alan and I'm sure Michelle and you've had this, nobody used to get fired for buying IBM back in my day, right? Nobody's going to lose any supporters by knocking digital infrastructure in the world today. They use it, they love it, but they want to sort of bat it away that actually it lives somewhere. And that brings us to this discussion that the cloud is real. It's a real thing. So everywhere, like when I was really interested in Alan, I'll ask you this about your own business as well, and how you measure it. So you have a platform, and you're trying to do best practices for a manufacturing 50 factories. You don't have people flying. You don't have people actually, all those carbon emissions to be where they need to be to analyze. Brilliant book here, How Bad Are Bananas? Yeah. And when you look at something like that and you see that 33,000 days of Zoom is equal to 2 return flights to Hong Kong. You know, digital. So what's better? Ship 2 guys to Dublin from Hong Kong to analyze data, or have them always on all the time analyzing it? So you see, that's the problem, isn't it? Everybody's gone very narrow, very deep on their little bit, but that's human behavior again, Michelle. Yeah. Oh, well, I'm doing fine. We're doing fine. We're grand. Yeah, no, we're great.
For sure. Yeah. And there's a question here actually from Damien Dalton. I just want to touch on it because I kind of really feel like it's part of this human behavior piece again. It's in a recent EY survey on sustainability in Irish industry, only 6% of surveyed companies saw sustainability is giving them a marketing advantage. Does this illustrate that we still need to educate the public and business?
You talk to that 6% HR department and you have a different answer because they're using it to attract talent, right?
For sure. Yeah.
Yeah. I mean, just on that, but maybe just to go back to the previous question, I think it's a very important point. Like, you know, when we look at companies' annual reports and balance sheets and P&Ls, you know, there's a set of rules around how they report their numbers, and they can't just make up numbers and hide debt and, you know, off balance sheet and all the rest. You know, ultimately, I think we're going to have to get to that point with carbon, you know, because there's so many rinky-dinks, Irish phrase, Dublin phrase, hopefully people know what that means, that you can get around, you know, inflating or deflating or whatever it is to make your numbers look better. So I think that's a very important, you know, clear set of rules, Sarbanes-Oxley equivalent to carbon accounting, and it's coming. It probably just needs to come quicker. I mean, on the carbon thing, I mean, look, we've been in the business for 12 years. And it's really accelerated over the last year or so. It's one of the weird byproducts of the pandemic is that companies are getting more and more serious about this. But, you know, it's still a 20-year, 30-year problem in people's eyes, you know, like Ukraine and energy prices and, you know, inflation and like is always going to trump, unfortunately. I suppose it's the brain's bias to focus on the here and now as opposed to what might happen in 20 or 30 years time in terms of rising sea levels, et cetera. And you can see that in any poll that, you know, people ask about, look, what's your top 1 priority at the moment? 3 priorities at the moment. It's inflation, you know, even war in Ukraine is number 5 or 6, and you know, climate change is 7 or whatever it is, you know. So people just generally focus on the immediate problem, whether it's health or education or inflation.
Yeah, for sure. And actually, just to kind of, we'll start to wrap up now. You know, one of those questions there, I'm not going to read the full question, but, you know, it is around, you know, how companies are incentivized or regulated around some targets. And I think it's the human behavior and the institutional behavior. And Garry, to your point around, you know, bringing talent in, that we need to go a hell of a lot further than regulation or like what's forced upon us. We need to be looking far more, you know, far further than that. I'm going to finish with one little question, which I think is a great one for everybody, from Connor Burns about where would you go to recommend more learning in relation to these topics?
Well, there's a world of podcasts out there. Probably is a good start, I would say.
Have you got, I'll put you on the spot now, Alan. Have you got a favorite one on something like this that people can go to, or just keep this webinar and repeat? That'd be grand.
Yeah. There's a good one called the Energy Gang. It's quite good. It's kind of a weekly one. It's got some high profile FT journalists on it, so it's quite good.
Nice. And certainly the book that Garry recommended How Bad Are Bananas. Great little read as well to get some, you know, lovely little nuggets.
Yeah.
Written by the brother of the dude that invented the internet, which is just a little sidebar. But that's great. Terms of reference for everything, from bananas through to Elon Musk's flight to the moon, you know, very important.
I would, I just put into the chat, if you want to share it, sustainability at Autodesk, you can read a lot about what we're doing for other customers. We also have a sustainability consulting group now at Autodesk that works with customers around the globe on their sustainability goals. And so we've just actually launched that in the last year so that we can not just, again, you know, reading our impact report, affect ourselves, but we want to affect our customers by offering that consulting services.
People are scared, aren't they, Michelle? People are scared. It's so daunting. It's so big. As an individual, how can you make a difference? You can't make a difference really, or you don't feel it when you put the yogurt can into the right box at home. So, you know, and a bit of a plug for what we're doing, but when you think about the DCs for Bees initiative that we do, it's doing great stuff, and but more than anything, it's actually helping people to do something, plant an orchard, meet somebody else, influence a community. I don't think that we with the digitalization, with COVID, we have gone further apart. We now have tools. Actually, by collaborating with each other, even at a community level, around an orchard or around cleaning the riverbed or something, it's amazing the mental and the physical effect it can have. And that power of the collective actually gets more momentum. And as you know, Michelle, having been a huge pillar of the success of the orchards in the community is coming back to industry now, to us, to say, wow, we want more of that. Can you give us more of that? Because we've got the enthusiasm if you can bring a few quid. And it's that simple sometimes. And I'm sure you find that, Alan, with the stuff you're doing up in Coolplanet, up the road with the schools. When you bring in a group of school kids, they're so enthusiastic, but they want to do something, right?
Yeah, exactly. Yeah.
And so I think this brings it nicely to a close. We're just at the top of the hour. Thank you so much, Amy, Alan, and of course, Garry, and everybody in the background who has helped to make this happen. And of course, to you, our audience, without which, sure, we wouldn't be here. We were just talking to ourselves. So about a month from today, yeah, we do it all the time. About a month from today, we're going to be launching our digital infrastructure ecosystem report. Keep an eye out for it. Everyone here in the Zoom will be getting it into their inbox anyway. Anybody watching live, just make sure you sign up so that you get it to your inbox when it's released. But thank you so much to our panelists. Really, really appreciate it again. And hope to see our audience here again soon. Thanks so much.
Stay safe. Bye.
Thanks.